There, here's part 2 of writing ionic formulas. Not all ionic compounds are made of just 2 elements. In the last video we did binary compounds. These are going to be polyatomic ions. So you follow kind of the same process if you're given the name. First you got to find them on the periodic table if applicable. So magnesium, that's an element because we find it on the periodic table. So find its oxidation number. But if you see something that ends with 8, that's a clue that this is going to be a polyatomic ion. So you'll need to look that up either on the internet or on your reference table. So if you look it up, you'll find that nitrate is NO3 negative. And this is all one thing. That means these atoms are all bound to each other, and as a group, they have one extra electron. So we still follow the same drop and swap process, but we need to use parentheses. So basically, see how I have 2 plus here? I'm going to need 2 of this whole thing in order to get my 2 negatives with my 2 positives to equal 0 altogether. So how do I represent this? Basically, I'm still going to drop and swap this 2 down, but I need to first put my NO3 in parentheses and then put the 2 here because I'm trying to say I have 2 of this whole thing. So this is how you'd write it down, magnesium nitrate. Not so hard, right? You can also have your cation be a polyatomic ion. I don't think ammonium carbonate is a real thing, but we'll just roll with it because it just is on the top of my mind right now. Ammonium is NH4 plus, and carbonate is CO3 2 negative. So same thing, we're going to drop and swap. We'll put the NH4 in parentheses, and this 2 comes down. So there's no need to put the polyatomic ion in parentheses if there's not another subscript on the outside, if that makes sense. So since this was just a 1, I don't need to do like this and put a 1. It's fine just how it is. The other thing, just to kind of reiterate this from the last video, let's say I have calcium carbonate. Remember, calcium will be a 2 positive just because of its location as an alkali earth metal. With the 2 negative, you can see here, if I was to drop and swap, they'd both have 2s. And then I need to simplify. So, since they're the same, this is the formula. So you guys can get some more practice. You can see it's pretty much the same process as writing the binary compounds, except you need to do a little bit more work. If you see something besides IDE, if you see IDE, we're going to learn naming next. IDE means it's an element as the suffix here. If you see 8, if you see 8, that could be a polyatomic ion. So if you see IDE, check the periodic table. Anything else, check your reference table for the list of the polyatomic ions. But that's all for today. Thank you for watching.